there is in fact one more thing that you need to know, and that is how to use this, the Doppler equation. Now this is one of the most complicated equations that you're going to need to use at the GCSE level, and I want to try to explain to you how it works. Imagine that you have two spectra, and at the moment these spectra are just blank, they're just rainbows, light split up into all of its colours. We want to make a comparison between light in a reference frame, like from our sun, compared to light associated with a moving galaxy away. So if we say that this is the spectrum from our sun, and this is the spectrum from a galaxy moving away, then when we look at those spectra, we should hope to see some dark spectral lines, kind of like this. And like this. Now, if we believe that this is the same spectral line, that spectral line has just been shifted, then we can work out the velocity of this galaxy relative to the Earth. So the very first thing we would need to know is what the wavelength of this line was originally. So we imagined that the sun is neither moving away or towards us as we go round it. It doesn't get any nearer or further away. So what we could say is that the wavelength in the sun's rest frame is equal to, and I'm going to make up a number, but we could actually take some real data here, say 555 nanometers. And this wave, this absorption line, has a wavelength slightly longer because it's been redshifted. So let's say that this one is 560 nanometers. A redshift has indeed gone on. And then we need to use this equation to try and work out how fast the galaxy is going. So looking at what goes into it first, we need to look at the difference in wavelength between this one and this one. And so what you can see is that this here is that again, except they've collected this term just there. So what we're going to do is we're going to take first the wavelength when it has been shifted, which is 560 nanometers. Now this is the bit that's tricky. You could convert it into meters. So it would be 5.6 times 10 to the minus 7 minus 5.55 times 10 to the minus 7. But then what we're about to do is we're about to divide it by another number to the minus 7. Now that would give exactly the same answer as if we never put it to the minus 7 in the first place. If we're having a number that's times 10 to the minus 7 and dividing it by another number that's times 10 to the minus 7, there was no point. So this is one of those few examples where I recommend not putting it into the standard form. What I would suggest is leave it with the prefix, because you don't actually need to change it in this one example. So what I'm trying to write here is lambda minus lambda naught divided by lambda naught. So this is equal to, well, lambda in this case is 560 minus what lambda naught is equal to, which is 555 divided by lambda naught, which is 555. Now this sort of sum looks a bit strange. Why are we taking one from the other and dividing by that same thing? We're looking at the size of the difference compared to the size of the measurement. So, 560 minus 555, no surprise, it's 5. So the change in wavelength is 5 nanometers. Okay, and we're going to divide that by 555, and we get 1/111th. So in decimal, it is equal to 0.009 recurring. I'm going to keep it like that for now, for a reason that will be obvious. Normally in science we don't do recurring, we prefer just to round things up. But this is equal to V divided by C. And C, you may remember from before, was the speed of light in a vacuum. So the speed of the light is 3 times 10 to the 8 meters per second. So if I have got that number, 0.009 reoccurring is equal to V divided by 3 times 10 to the 8. You can see I need to multiply this by that to get this. So final step, the V is this number times 3 times 10 to the 8. And we get a speed of our galaxy, the recessional velocity, nonetheless, 2702.7. Look at that. Meters per second. Now you see what I've done here. I'm so used to writing meters seconds to the minus 1 at A level. Forgot at GCSE. We write it like that. So what we've got basically there is it's going at 2,702,702 meters per second. So we were able to work out just how fast the galaxy is moving away from us from the Doppler equation. Now the very last thing I want to talk about is the type of objects that we expect to see the Doppler effect applied to. With GCSE, we'd only be interested in galaxies. The nearby stars, we are not interested in. The planets, we are not interested in. This is simply galaxies that are far away. Now, nearly every single galaxy in the universe is moving away from us, with the exception of Andromeda Galaxy. Now, Andromeda Galaxy is not redshifted, it's blue shifted, because that galaxy is indeed falling towards the Milky Way for a collision at some point in the future. And on that cheery note, this is the end.